Hey guys, today we're going to do sum to product identities. This is just the back of the note sheet that we did yesterday. So it's going in the reverse order. So starting with a sum, changing it into a product. So if you look at these identities, we have sine plus sine, we have sine minus sine, then cosine plus cosine, cosine minus cosine. You want to change it into a product, meaning there would not be any more plus or minus signs. We would simplify that, and it would all just be multiplication. Okay, so let's look at this one, number 6. We have cosine of 8x plus cosine of 2x. So they're both cosine, and they're being added. So when you look at your identities, that is this one right here. So we're going to be following this pattern next to it. So the first angle is always A and the second angle is B. So for us, 8x is A and 2x is B. Let's actually make this a little bigger. Okay, so if I follow this pattern, it starts with a 2. Then cosine of adding the two angles divided by 2. So that would be, I think I need to make this a little bit bigger. 8x plus 2x, then divided by 2, times cosine again, but this time they're subtracting the angles and dividing by 2. So 8x minus 2x divided by 2. Okay, so then now we just simplify as much as we can. This would still have a 2 out front. Cosine of, well, 8 plus 2 is 10, so that would be 10x over 2 times, over here, 8 minus 2 is 6x over 2. Okay, and they are both even, so we could actually do the dividing by 2. So this would be 2 cosine of 5x cosine of 3x. Just 10 divided by 2 is 5, and 6 divided by 2 over here is 3. And that's it. It's simplified as much as it can. See how there's no more plus signs or minus signs? That's what you want. Just everything all next to each other like that. Okay, let's look at the next one. The next one is sine 3 beta minus sine of 6 beta. That weird kind of looking b, that's a beta. So sine minus sine. So I'm going to look at my patterns again, my identities. We need sine minus sine, which is this one here. So now this is the pattern that we're going to follow. 2 cosine, add the angles divided by 2. So for us, 3 beta is A and 6 beta is B. So 2 cosine of 3 beta plus 6 beta over 2. So we did adding divided by 2. Now it's going to be sine of subtracting divided by 2. So 3 beta minus 6 beta over 2. Okay, so let's go through and simplify whatever is inside of those fractions. So 2 cosine. Well, up here, just adding them up, 3 plus 6 is 9. So that's going to be a 9 beta over 2. And then the next one, subtracting, 3 minus 6 is negative 3. So negative 3 beta over 2. Okay, so this time around, we talked about this yesterday. If you have a negative sign inside of your parentheses, you should use your even odd identities to simplify that a little. So even odd identity. This time around, it's for sine. So when sine has a negative angle on the inside. So sine of negative theta. What does that equal? So I'm going to go back to my even odd identities at the very beginning, and let's take a look. Okay, so right here, we're looking for sine of a negative angle, which is this one here. So what happens is the negative that's in the inside, we take it out. Like it's not going to be a negative angle anymore, but it's going to move out to the front. There needs to be a negative sign in the front. Okay, so let's go back to ours. So this becomes negative sign of theta. Okay, so this negative sign, I would move it in front, or this, I would move it in front right here. But then even that's going to look weird because I have multiplied by negative sign. So we're actually going to get that negative and move it all the way to the front over here. So this becomes negative 2 cosine. Here's where you would try to simplify, but 9 divided by 2 is 4.5. We don't want to have any decimals either, so just leave it as 9 beta over 2 times sine. We're going to take off that negative because we moved it to the front. But then 3 divided by 2 also does not simplify, so just leave it as 3 beta over 2. And that's our final answer. All right, now let's do one more for practice. Number 8, negative 10 cosine of 3 theta plus 10 of cosine 5 theta. So first thing before we even look at the identity is I notice that they both have 10, so we really should take that out. And whatever the sign is of the first one, so since it's negative, we should divide out a negative 10. So I'm going to use brackets here. If I got negative 10 cosine 3 theta and divided by negative 10, these would cancel, and I would just have cosine 3 theta. Then the second one, if I were to divide by negative 10, the 10's cancel, but I still have that negative sign. So this is now going to become minus cosine of 5 theta. So this is why you have to factor out the greatest common factor first, because it started out with a plus sign, but once we divided by that negative, it became negative. So the identity we're going to look for is cosine minus another cosine. Cosine minus another cosine. So not this one. Let's see. Over here. We're going to follow this pattern. So this one starts with a negative 2. Okay, so back to where we have. I still have that negative 10. It doesn't go anywhere. But now, I also have a negative 2. Okay. Sine of adding the angles divided by 2. So sine of 3 theta plus 5 theta over 2 times sine of subtracting divided by 2. Three theta minus 5 theta over 2. Okay, so right here, negative 10 times negative 2, that's going to give me positive 20. So I'm going to go ahead and put positive 20. Sine. Then here I have 3 plus 5, which is 8. But then divided by 2 would give us 4 theta. And then on this next one, 3 minus 5 is negative 2. Negative 2 divided by 2 is negative 1. So we have sine of negative theta. So the good thing is that we did this already. Anytime you have a negative sign inside of the parentheses, you really ought to fix that. And we already looked at our even odd. And we know that anytime that there's a negative inside when it's sine, you get that negative and you move it out front. So for us, this negative is going to move all the way up front over here. So this is going to become negative 20 sine of 4 theta sine of just 1 theta. Okay, so these three that we just finished doing, we were rewriting the expression as a product. So we were basically just simplifying. The bottom two, they want us to find an actual value. So anytime we're finding an exact value of something, we need to use the unit circle. So those bottom two here, use the unit circle. So I'm already prepared. I have my unit circle down here. So we'll refer to that when we need to. Okay, so it says find the exact value. We have 3 over 2 times sine of 345 plus sine of 75. 345 would be our A value. 75 would be our B value. So I'm going to keep this 3 over 2. Times. But now let's actually look at the recipe for sine times, or plus sine. Sine plus sine. So I think it's the only one that we have not used yet. This one here. So it starts with a 2. And then it has sine of A plus B over 2. Okay, so we got to put a 2 there. But then sine of 345 plus 75 over 2. So I got the two angles, add them up, divided by 2. Then the next part of that identity has cosine of subtracting. So cosine of 345 minus 75 divided by 2. Okay, so that's the basic identity, but now let's simplify what we can. 3 over 2 times 2, remember that whole numbers, so that 2 technically has an invisible 1 underneath. So we'd cancel out those 2's, and all I'm left with is the 3. So I have 3 sine. Now in here, let's actually figure out what that simplifies to. 345 plus 75, I think that's 420, divided by 2 is 210. And then the next part, 345 minus 75, that's 270, divided by 2 is 135. Okay, so sine of 210 and cosine of 135, those should be on the unit circle. So I'm just going to bring down this 3 that's in front. So I brought it down. But now let's find the value of sine of 210. So to the unit circle, 210 is down here. And out of these 3, sine is negative 1/2. So negative 1/2 times. Now we need to find cosine of 135. 135 is right here. So there's the values for 135. Cosine is negative square root of 2 over 2. Okay, now we just go ahead and multiply everything across. So like we said before, whole numbers have an invisible 1. So let's just do all the numerators. Negative square root of 2 times negative 1 times 3. These negatives cancel each other out. So I would just have 3 square root of 2. Then in the denominators, 1 times 2 is 2, times another 2 is 4. You should check to see if anything simplifies, but in this case, it doesn't. That's already our exact value. If you want to check your answer, you can type this expression into your calculator, and then type in this fraction into your calculator, and they should give you the same decimal. Okay, now let's do one last one. Cosine of 11 pi over 12 minus cosine of 5 pi over 12. So we haven't really been dealing with radians, and they are a little bit difficult because you have to think of fractions. So it's going to be easier for us if we just convert that into degrees. So this would be like saying cosine of 165 minus cosine 5 pi over 12 is 75. So all I'm doing is, in my head, I'm doing the 180 over pi and converting that way. Okay, so let's do it this way. That means that 165 is our A, 75 is our B. We need to look for the identity that has cosine minus cosine. Okay, so cosine minus cosine is this pattern here. It starts with a -2, then sine of adding the angles divided by 2. Okay, so starts with a -2, sine. We're going to add those two angles, so 165 plus 75, and divide that by 2. Then the next part of that identity has sine of A minus B over 2. So now we would have to subtract. Sine of 165 minus 75 divided by 2. Okay, so now let's actually figure out what those angle measurements should be. 165 plus 75 and then divide by 2. I wouldn't struggle with it too much. Just put it into your calculator. This gives you 120. And then sine, same thing here. Don't struggle too much. Just put it in the calculator. And that gets me 45. So I'm going to bring down the -2 in the front. But now we need to go to our unit circle and find sine of 120. So let's do that first. Here's 120. So sine is square root of 3 over 2. Times, and then we need to find sine of 45. So here's 45. Sine is square root of 2 over 2. Okay, so now we're just going to multiply those across. That 2, since it's a whole number, imagine that there's a 1 underneath. So that already tells me that I can cancel out one of these 2's. 2 on the top, 2 on the bottom. Cancel out. I think that's all I can cancel right now. So now let's actually multiply. So I have a negative sign. I need to keep that negative sign. Square root of 3 times square root of 2. So this would become negative square root of 6. Then on the bottom, 1 times 2 just gives me 2. And I can't, like, I know 6 can be divided by 2, but you can't do that because this 6 is in the square root and this 2 is not. So we're just going to have to leave it like this. All right, guys, so this is sum to product identities. So this is the back of the paper from yesterday. So make sure that you have both sides filled in. And I also posted the notes into our Schoology. So if I was going a little bit too fast, you can go and look at those notes. And just know that not tomorrow, Monday, when I get back, we will go over this really quickly again. Right? Let me know if you have any questions.